Thanks, everybody. Which button do I press? Oh, the big green one with an arrow on it. Thank you to MLA for asking me to come and talk, and it's I hope I've got something interesting to say to all of you. It's a real privilege to talk to a meeting like this. The MLA team asked me to cover three main points this afternoon, which I think kind of hopefully will round out what's the underpinning technology platform in place, in a sense, for the next generation that we're all excited about exploring. So I'm concentrating in a sense on breed plan and what the possibilities it creates, and I'll be covering those three topics, a little bit about Singlestep, then about Australian R&D, and then some of the future opportunities. I just want to start out by a little bit of clarification of what we mean when we talk about single-step breed plan. Some of you in the room will know about what I've called their ordinary breed plan. So it's the breed plan that's been around now for nearly 4 decades. And breed plan is all about identifying the genetic merit of animals. It does a whole bunch of very important things. I'm not going to go through every one of them, but it's basically about separating out non-genetic influences on the performances of animals from their underlying genes and providing a language to describe those genes. A couple of very important points. Obviously, it uses pedigree data and performance records. It uses the information from all the traits that have been recorded on those animals together, so it's called multi-trait. It uses information from overseas where that's available. So, for instance, the Angus evaluation uses data from North America. And there's a wide range of traits that EBVs are produced for across a whole bunch of areas of how genetics can impact value chain profitability. It's quite powerful software that's used for it, so it's running monthly for most breeds now, and where the data flow is required, it's run more frequently, so it keeps up with people's need to make decisions. Now, single-step breed plan is really quite, in many ways, it's a big step. Sorry about the pun. It's like Neil Armstrong's line on the moon. Single-step is the term that's used to describe doing all of those things, but adding in DNA information or genotype at the same time and using it simultaneously with the pedigree and performance information. So it incorporates this thing called genomic prediction, which I'll explain in a minute. And we currently have in Australia what I'm fairly sure is the only fully multi-trait single-step evaluation going for beef cattle. American Angus may now be doing something almost identical, but we're doing fully multi-trait single-step evaluation in a number of breeds, as you'll see in a moment. The big thing about single-step is it's using genomic information, and I'll outline how that influences things. The basic principle behind genomic prediction is that somewhere we record and genotype a bunch of animals for whatever things it is that we're interested in, that we want to be able to pick them genetically for. You have to measure lots of animals. Ben's just been talking about 30,000. You should be measuring them for things that contribute to profit, and you read their DNA. They constitute the reference population, and once you've got that, you can just take a DNA sample on a young animal, for instance, and basically what you're doing is looking for patterns in the DNA that are associated with performance, and if you find those patterns in the young animals, you can predict their genetic merit without having to record them for anything. But the reference population is the really key thing to it. But so that reference data is now feeding into single-step breed plan for several breeds. And the consequence of that is that basically you can take a tissue sample at any age of the animal. It could be at birth, it could be actually as an embryo, and you can estimate its genetic merit, get its EBVs simply using its DNA. And the real game changer about that is that you can get much more accuracy than you would normally be able to get on that animal at that age. And I tried to illustrate this by this chart, where along the x-axis, the horizontal axis, we're looking at the accuracy you would have for a trait in normal breed plan, and up the vertical axis we're talking about what you get from single step. And there are there's a dotted line going through from 0 to 1, and that's if we had no change in accuracy, everything would be on that line. But if we've got a reference population and we're using single step, then we can get lifts in accuracy, particularly in the animals that were previously not very accurately evaluated. And that's what the three coloured lines show. If you look at the sort of reddish-orange line, that's starting out at about 20% accuracy from single-step breeding value for animals that would have otherwise had zero accuracy. So that would be, for instance, an animal at birth that you didn't know anything about the parents, you would have zero accuracy EBVs. Well, if you've got a reference population that's generating 20% accuracy, at birth you'll get EBVs of 20% accuracy. And you can see that as you move from left to right, the existing accuracy reflecting more information, you still get a lift from the genomic bit, but it gets less and less as the accuracy goes up, or the pre-existing accuracy goes up. And a simple way to think about that is, as we go from left to right, the first 25 to 30% or so for existing accuracy is likely to be animals that don't have a record of the particular trait themselves, but with genomics, they're going to get accuracies that have increased in accuracy by anything up to 60%, depending on the size of the reference population. So for animals that don't have a record for a trait, genomics is really, really useful if you've got a good reference population. For animals that do have a record for the trait you're interested in, you can still get some lift in accuracy, and that's the middle section, because you're getting some information about their genes from all the animals in the reference population. You're picking up some clues that you don't just get from the animal itself. For animals with very high existing accuracy, such as sires with plenty of progeny, you only get small increments from single step. You get a little bit, but again, it depends on the size of the reference. But the really big thing, I think, is that single step really allows you to make good decisions about animals that you didn't previously know very much about. The animals down to the left-hand side of that chart. And we're seeing exactly that effect, for instance, in the Brahman single step for days to calving. The fertility EBV, you can go and genotype young bulls and you're getting accuracies of around about 33% on animals that have obviously got no calving records themselves because they're bulls, and limited female relative records. Simply by pulling a tail hair, you're getting EBVs with accuracies of 30-35% for days to calving. And that's kind of the game changer, I think, of single step. It's implemented now in those breeds to the left-hand side, Brahman, Hereford and Angus, and we anticipate Wagyu within the next month or so, and later in this year we anticipate moving to tropical composites as well. So a number of the major breeds in this country are well down the track of implementing single step. So that was a quick run through single step. It's a really, really important development for Australia, and a lot of people did a lot of hard work to put it in place, and obviously MLA funding helped. But it's in a sense, what does it open up in the future that I'll be touching on in a second. Question was put to me by the MLA team, why should industry support and continue investing in Australian evaluations? And it's a very good question. We all pay for the research and we want to make sure we're getting something out of it. I think ultimately the answer is that if we want to breed cattle or manage cattle for our production conditions and our markets, we need to know about their genetics, and to do that we need to do research in Australia. How do the genes for growth rate in whatever breed or cross it is, how do they work in Australia? Simply pulling in information from overseas is not guaranteed to work. We can't get a free ride by importing someone else's information. We have to do some work in our own country to keep on making sure that the EBVs are as accurate as they can be for the traits that we're interested in, and so people can get the right animal for the job. We also need to make sure that the evaluations we're running, the analyses, are actually keeping pace with people's demands. It used to be that there was kind of one evaluation a year, and then it became twice a year, and then 4 times a year, and now it's monthly or even fortnightly, and that'll probably get faster because more and more data is coming in from more and more places, and people want answers quicker, and we need to make sure the machinery can deal with that. We also need to bring in new traits so that any trait that's contributing to profit, in principle, you should have an EBV for it so you can help make better decisions. And we also need to continue working out the best possible ways to use DNA information and to use much, much bigger volumes of it that we anticipate coming. So there's lots of reasons, I think, why we need to continue investing in R&D in this field in Australia. The question was put, why are we world leading? And I think it's fair to say we are. BreedPlan is a very, very comprehensive multi-trait system. It uses Singlestep, and aside from American Angus, I don't think anybody else is doing the full combination of full multi-trait and Singlestep in beef cattle in the world, and there's only a couple of people who are actually or a couple of countries are actually doing Singlestep. So that's pretty good. We should be proud of that. The breed object dollar indexes are a completely unique and very powerful system. They were developed in this country working with breeders and breed societies, and they help describe genetic merit for total value chain profit, and that's exactly what they do. It's a really, really powerful system. BreedPlan is already using commercial data and some crossbred data in several of the evaluations. So the system, the machinery, has the capacity to do the things that, for instance, Tom Bull was talking about, bringing together data from different breeds into an analysis. The machines can do it. And something that's extremely important, particularly in the context of doubling the rate of genetic gain, is the leading beef cattle breeders in this country in a number of different breeds are making genetic progress for profit as fast as any breeders in the world in beef cattle. And that's not an exaggeration. I know, and people like Ben and David and others know our counterparts in other countries. We know the sorts of rates of progress they're making. We know the sorts of progress that stud breeders are making. And there are people in Australia using BreedPlan technology to make very high rates of genetic gain. So we know it's possible, we know it's working. We just want more people to be doing the same. How will our genetic evaluation remain at the forefront? There's a number of things we're working on. When I say we, AGBU is part of that. Working with people like Ben and others is part of increasingly a sort of portfolio or a collaborative approach. So the approaches to using DNA information beyond the current Singlestep are already being tested. We're looking to expand the multi-country aspect of genetic evaluation, so bringing in data from other countries to add to our own evaluation and probably sharing Australian data with other countries as well. Multi-breed, both Tom and Ben have talked about this. The capacity's there. We definitely need some R&D data, particularly for those head-on comparisons, particularly for the hard-to-measure traits, including fertility. But the machinery is there to do it, but that's very obviously a high priority to really progress that to implementation. Producing meaningful genetic evaluation for all points in the value chain. This ties in with what Jason was talking about. We have the capacity to do that now. For instance, pulling tail hairs on commercial cattle before you put them on feed, that could be dealt with today. They could get EBVs if that's the form of information people want there. But I anticipate a big expansion of that, and I also anticipate an expansion in the number of traits for which there'll be EBVs available, and I'll touch on a few of those in just a minute. Just to reinforce the point about multi-breed and crossbred, the need for the head-on comparison data to make robust EBVs is really important, and it's got to reflect the trait groups and the main environments. David Johnson did work on multi-breed genetic evaluation several years ago now and showed you can do a really good job for growth and carcass traits in a couple of groupings of breeds, but once it comes to maternal traits like fertility and so forth, we just do not have the data to be sure that we're making robust evaluations. And I think R&D is going to have to help there. I think the big payoffs will be kind of twofold. First of all, people who want to breed composites, such as like what Tom Bull was talking about, obviously multi-breed evaluation will help. They just get the best genetics from wherever, but it will also clearly stimulate the individual breeds and breeders within a breed to select for more things faster. So it's a really valuable thing to aim for, but it is going to need some R&D basically in data collection. Very quickly, this is just some of the sorts of ideas I've got about future traits that we might be looking at. You could make this list as long as you like, really, but lifetime productivity, there's R&D going into that now. Diseases, I don't see any particular reason why cattle should get sick. Genetics can help solve that problem. So worms, BRD, heat tolerance, Ben mentioned a nice example. The nutritional content of meat, instead of just saying it's good for you, we can make sure that it is. It's got, you know, iron and zinc and omega-3s and so forth. Different sectors will have different needs for information, so there might be specific feedlot traits that we need to produce EBVs for. There's no particular reason data shouldn't be coming back from restaurants or supermarkets to feed into customer liking and stuff like that. There's no reason why there couldn't be EBVs there. Feed intake, methane production, in a sense there's no limit to what you could produce EBVs for, but they, no matter which they are, they will need data, and that'll be through that mixture of various sources that Ben touched on. And we've always got to concentrate on, is this actually contributing to profit? If it's not, it's just using up computing power. That's future traits. There's plenty of new applications that one can think of. Ben's done a really nice job of covering most of these, I suspect. Continuous evaluations, like once every day or something, could basically be achieved now, at least for animals with only genotype. I would expect we'll move towards faster and faster cycle time. Race-side testing, Ben's covered that really, really nicely. We just need rapid genotyping. Screening of commercial cattle will become a reality fairly shortly, I would think. We can certainly trial it right now. You could be pulling tail hairs at birth, obviously, and say, what are we going to do with this animal, whether it's a breeding animal or it's going to go to the feedlot or it's going to go to dog meat or whatever. The other, there's one that's not on here, is much, much more interest in different ways of collecting phenotypes, getting more and more phenotype data, you know, satellites, pasture monitoring, et cetera, et cetera. We'll need to be working with that. And also coupling genomics with reproductive technologies. So flushing females that you've selected genomically very young to really scale up the breeding program will make it faster. So to finish off, just a couple of points. First of all, what is possible? The genetic gain we're making in this country in beef at the moment is worth about somewhere between $30 to $50 million extra money per year, and doubling that is quite feasible. And that might sound like some geek from Armidale or somewhere saying it, but in fact, there's plenty of people who are making progress at much faster than twice the average in their respective breeds. So it's being done. We just got to lift the mainstream, if you like. It's worth a lot of money. I've done my sums over 15 years, $2 billion, but it's actually a couple of $1,000 profit in real terms in every producer's pocket every year if we can double the rate of progress. For bull breeders, I would expect they're just going to be making faster and faster progress, and some of them are going to be part of the reference population, and that's a very, very valuable role. And I think we're going to see a lot of expansion of people who run a smallish, tight nucleus operation where they're recording and genotyping everything, and then very large multiplier operations. So sort of thing that some people do in the north, there's no reason that couldn't spread. For producers, I would expect that feeder cattle and replacement heifers will be screened genomically routinely, and animals' genetics will be matched to the production market pathway that people want to choose. And I'll touch on the last point there in a minute. For other value chain partners, and I think this is where the disruption is going to start really happening, things like through chain contracts for genetics have to start being thought about. Some people kind of do it now, not very many, but anybody who's running a processing operation or a feedlotting operation who doesn't know the genetics that's going through their system is basically just holding up dollar notes and putting a lighter to them. It's the difference between knowing the genetics and not is frightening. And that will feed back into saying, okay, if you want to supply cattle to my feedlot or to my supermarket or stuff, this is the specs on the genetics, and if you can't do it, go and talk to someone else, because there is just too much money is being lost in that at the moment. So our little session is called Disruptive Technology or something, and Tom was an extremely disruptive child, which is fairly obvious. But I just want to touch on two disruptions. The first one is simply tapping into genetic progress. Some of you here are already doing that. You're buying bulls from people who are making really good genetic progress, and you know that life is different from what it was like before. It's night and day whether you're getting genetic progress or not. And I'm not just talking about growth rate, I'm talking about everything that affects profit through the value chain. That is the biggest disruptor any livestock industry can hook into. But the second one, and this is going to be the organisational or industry challenge, is how do we make sure we're getting enough phenotypes of the right type and the right quality, and what sorts of partnerships and collaborations are going to be needed to achieve that. There's going to be a lot more almost organisational change than technological change, and that will be the second big disruption. Thank you.